Hey everyone, I hope you're doing well today. In this video, we're going to talk about graphing rates and ratios. Let's start by looking at a ratio where we have 3 burritos for every 12 tacos. Writing a ratio of burritos to tacos, we can write it in fraction form as 3 to 12. In order to graph this ratio between burritos to tacos, we first want to find a unit ratio. While we have 3 burritos for every 12 tacos, we can divide top and bottom by 12 to find out for one taco, we have 0.25 or 1/4 of a burrito. This 0.25 to 1 represents a unit ratio, which just means how many burritos there are per one taco. While you could say that there are 3 burritos for every 12 tacos, we could also say that there are 12 tacos for every 3 burritos. To get this ratio of 12 to 3 to a unit ratio of per one burrito, we can divide both top and bottom by 3, and we find out that there are 4 tacos for every 1 burrito. This is also a correct unit ratio, and it's how many tacos there are per 1 burrito. For a ratio of 0.25 burritos for every 1 taco, we can make a table. Let's let B represent the number of burritos and T represent the number of tacos, and since this unit ratio is per 1 taco, the tacos are going to go on top. For each of these given amounts of tacos, we'll have these respective amounts of burritos. And for a unit ratio per 1 burrito, we can make another table, and the burritos are going to go on top this time because it's per 1 burrito. Given these numbers of burritos, we'll have these respective amounts of tacos. And again, since the unit ratio on the left is per 1 taco, that's going to go on top, and for the unit ratio on the right, since it's per 1 burrito, the burritos go on top. When dealing with ratios and rates, once you have a table of values, you can then plot them on a coordinate plane. The tacos will go on the x-axis and the burritos will go on the y-axis. We'll count by ones along the x-axis while counting by 1/4 along the y-axis. We can then plot our ordered pairs to make a linear graph. 2 equivalent ratios we can see along this graph is that we have 3 tacos for every 3/4 of a burrito and 5 tacos for every 5/4 or 1 1/4 of a burrito. And to the right, when our ratio is per 1 burrito, the burritos are going to go along the x-axis and the tacos will go along the y-axis. We can go by ones along the x-axis and go by 4s along the y-axis. Plotting the ordered pairs on the coordinate plane, we can then connect the dots to make a linear graph. We can see that for every 2 burritos, we'll have 8 tacos, and for every 6 burritos, we'll have 24 tacos. Again, make sure you remember that whatever it's per 1 of, that's along the x-axis. So tacos are on the x-axis to the left, and burritos are along the x-axis to the right. Now let's take a look at a rate together. Let's say that your computer is downloading a file and it has downloaded 64 megabytes in 4 seconds. And for a rate, we're comparing 64 megabytes to 4 seconds. I'm going to use the variable m to represent the megabytes and the variable b to represent the time. Thinking back to what you know about linear equations, we're going to let the independent variable be time in seconds, and have the number of megabytes be our dependent variable. Writing this as a rate, this will be 64 megabytes for 4 seconds. To find a unit rate, we'll divide top and bottom by 4 and we'll get 16 megabytes per 1 second. Therefore, we know that this computer can download 16 megabytes in 1 second. Now that we have a unit rate, let's fill in a data table. Represented by the variable b, the number of seconds will go on top, so we have 1, 2, 3, 4, 5, and 6. And on bottom we have the number of megabytes, which is going to be 16, 32, 48, 64, 80, and 96. Our independent variable always goes on the x-axis, and our dependent variable goes along the y-axis. Labeling the x-axis, we have b, which is the number of seconds, and we have 1 through 6. And labeling the y-axis with m, we have 16, 32, 48, 64, 80, and 96. Plotting the ordered pairs we find in the data table, we now have a linear graph. Again, along the y-axis we have the number of megabytes, and to maybe label this graph, we can call this download speed. Looking at our graph, we can clearly see that in 4 seconds we'll have 64 megabytes, in 6 seconds we'll have 96 megabytes, and in 1 second we have 16 megabytes downloaded. Using our standard x's and y's, we could write the linear equation y is equal to 16x, but more specifically for this problem we can say m, or the number of megabytes, is equal to 16 times the number of seconds. At this point, we just want to make the connection that the coefficient for the number of seconds, or the 16 here, represents our unit rate. And let's just look at one more example. Suppose that while training for a 5K, you run 45 miles in 9 weeks. The two quantities we're comparing here is that we have 9 weeks, which I'll use W to represent the time, and this is our independent variable. And we have 45 miles, which I'll use M to represent the number of miles, and this will be our dependent variable. As a rate, we can write 45 to 9, or 45 miles to 9 weeks. And dividing top and bottom by 9, we can get a simplified rate of 5 to 1. An equivalent rate to running 45 miles in 9 weeks is this unit rate of 5 miles per 1 week. Showing this relationship using a linear equation, we can write y is equal to 5x. More specifically for this problem, we can say m is equal to 5w. The number of miles you run depends on the rate, which is 5 miles per week. And really important, this 5, which is our coefficient, represents our unit rate. Filling in a table here, the independent variable, or the weeks, are going to go on top, so I'll put w, and then 1, 2, 3, 4, 5, and 6. And the number of miles is our dependent variable, which goes on bottom, so we have m, and we have 5, 10, 15, 20, 25, and 30. Now that we have a complete data table with a bunch of ordered pairs, we can throw that onto a linear graph. Looking on a coordinate plane in quadrant 1 here, w is along our x-axis, and we have 1, 2, 3, 4, 5, and 6. These are the number of weeks along the x-axis. And along the y-axis, we have m, which is the number of miles, and we can write 5, 10, 15, 20, 25, and 30. These are the number of miles. For a title, I'll call this graph 5K training. And plotting these ordered pairs from the data table, we have these points, and if we connect them, we get a linear graph. Here we can see our unit rate, where in 1 week we can run 5 miles, in 3 weeks we can run 15 miles, and in 5 weeks we can run 25 miles. These are all equivalent rates. So at this point, it's my hope that you can now understand that when you have equivalent rates or ratios, that we can actually just plot those as ordered pairs to create a linear graph. Whichever variable that you're finding per one of will always be our independent variable and will go along the x-axis, and the other variable will go along the y-axis. Our unit rate is super helpful in that it tells us what our coefficient is in our linear equation, and at the end of the day, all the equivalent ratios or rates are really just ordered pairs that we can plot together. It's important to understand that rates and ratios just represent constant rates of change, and they're related to linear equations. If you found this video helpful, please give it a thumbs up, and as always, keep up the great work, and I'll see you in the next one.